Actually, I would like to know little more about.
Let me take, I think, dropped the connection.
Am I audible now?
Yes, yes, sir. Audible.
Yeah. So the participants are faculties
Yes, sir.
and all have engineering background or mixed
Yes, engineering background. Majorly is engineering background.
engineering background. Okay, very nice. So basically, this session has means we will discuss about the philosophy of data science and basic mathematics like linear algebra, constant and unconstant optimization, basic of set theory, and of course, probability theory is also if time permits. And these things are like we know everything out of this, but we will discuss how to use these things in case of data science and how it is a backbone of data. Nowadays, we are in decision science moving more towards feasible solution compared to optimal solution. And even finding this feasible solution very close to optimal solution is not a difficult task considering the computational capability being developed these days. So the thing is now your job is not only to do calculation. Calculation was shifted long way back. Now then you went to adopt this even softwares, and software were doing calculation on behalf of you, but you are not aware about what is actually happening inside that. So that another thing is we should be sensitized about not exact calculation, but the purpose, very purpose behind doing that. So that should be always clear, and that's why this refresher course is like you discuss all things together. No, all of you may be the best in linear programming, maybe you will be best in linear algebra, maybe you will be better and this differential equation, maybe you have strong command on this calculus. No, I'm not again saying that calculus of even of 12th standard, you maybe have studied about divergent curls and everything, engineering in mathematics you have gone through. So with all this exposure, you should be able to integrate things and understand what is actually happening, because what I have seen here in data science, people don't understand what exactly they are doing. Even not only quantitative, I think this workshop is about quantitative methods. Qualitative methods also involve a certain level of mathematics behind that. No, so you should be sensitized with this. Even what I always keep saying that methods will come and go, but the basic mathematics will remain there, and the people who will be having liking for these things will do wonder. No, and the job of this people like you academicians of course is shifting, not it's not only on analyzing the result. No, you go and you find out on Google and you'll find out how to analyze the output of SPSS. Of course, everyone is doing that, but without knowing that why we are doing that, that's the biggest concern. Another thing is there, we should understand, mic is mute. No, my mic is not mute. Am I audible?
Yes, yes, sir.
Yes, you are audible, sir.
Yeah, I'm audible. So the thing is, what I advocate is pattern detection is another area where you should think about, no, finding out pattern from the data. Pattern from the data, right kind of data. Before that actually starts, right No, people apply techniques. Most of the time I have seen people are applying t-test or anything test without knowing which type of data they should apply. So ask these type of questions. No, your inference in inferential statistics is wrong if it is based on wrong kind of data. So these type of sensitization is required whenever you teach your students also. I will not discuss certain things which are too much means difficult or what, because I was not aware about the difficult expertise level of, and I should not underestimate your expertise level also, because I am also engineer and I believe every engineer has gone through engineering mathematics, Krasnik or Grewal, and you people are competent enough. But we will try to integrate things using certain examples, using certain application, and how to use it in data science. And I'm saying data science is actually subdomain of decision science. In fact, decision science I will start with, and some of the take away message will be from this lecture is that we are moving towards pattern detection, no, because uncertainty is rising, and you will use your data science for decision making. So those kind of pattern, how you can detect whether that is manufacturing, whether that is healthcare, or whether that is aeronautics, anywhere you should find out pattern detection capabilities. No, so that's your contribution. I have seen there is a long gap between academia and um, this industry. No, so you should understand their problem, you provide them feasible solutions. So that's where you fit in actually. So with these words I will like to start, and okay, let me share my slides because that's also required. And share slides, don't worry about these slides are not something like which is top secret. I have prepared certain I have taken from book also Wiley, certain I have taken from MIT resources. So don't worry about that. And you will see these things, the small and even simple things and integration is being taught at MIT level. No, so we actually make our life very complex. So complex calculation, of course, computer will do, but you should know where what actually you are doing, and for that this session is. So as suggested by organizers of this workshop, this session is about mathematical foundation for data science, and I'm your very fortunate to be with you. And this is first occasion I am interacting, or I am being associated with this college, which is very reputed. Uh, so the agenda for the session is what is the decision making? Why do we study decision science? Then we'll come to data science and math skills. On that, we will be discussing building block and set theory. Of course, that all starts with set theory, whether that is probability you'll going or statistics you'll be going on, in or whether you'll go for the extension of set theory will be your fuzzy set theory, which I think some of people already use it without even in MCDM techniques, you use it extensively. But the set theory I will be discussing. Of course, we can discuss about the membership function of this set theory, whether this set is crisp theory, a crisp set, or it's a fuzzy set, what is differentiation. If you want to go on that level, and if time permits, I will go in that also. Cartesian plane, sorry, plan wrong, it is plane and coordinate geometry, how it is evolved. Relation function and graphs, constrained and unconstrained optimization. If any one of you is from supply chain or operation, you will be knowing that what are these constrained and unconstrained optimization. Then the probability theory, and then certain take home messages. So this 2 hours belongs to mathematics, which is actually my interest area. And I love teaching mathematics and used to teach mathematics also part-time, of course, gratis in Delhi. So what is decision science? The process of decision making typically involves several steps. Identify the problem or the need for a decision, whether you require to take decision or not. These steps involve recognizing the existence of the situation that require a decision to be made. It could be challenge, opportunity, or a goal to be achieved. So all of you who use this goals which you already do in case of inferential statistics, which is rather a deductive kind of, in which you actually propose certain hypothesis, you collect data, and then you gather information to prove that hypothesis right or wrong. Once the problem is or hypothesis identified, relevant information and data need to be collected. This information could come from various sources: research, reports, experts, personal experience, qualitative, quantitative, whatever it is. And always remember this, wherever I go, I advocate qualitative and quantitative both are important. Sometimes qualitative is more important because it is very difficult to measure everything. And that is called McNamara fallacy. We generally neglect those things which we cannot measure. And that is actually wrong approach that I can discuss in some other forum. But identifying alternatives, generally your decision making will be identifying alternatives. Out of these, you'll be selecting whether that is supply chain problem or whether that is a health technology assessment problem, technology A versus technology B, drug A versus drug B you'll be taking. So this is general decision making process. Then you evaluate alternatives. This I should take or that I should take. So evaluating alternatives, you can go for economic, you can go for mathematics model already available, you can go for something like simulation. Even in simulation, you will be using either normal distribution like Monte Carlo simulation, or you can go for system dynamic simulation, where you will be actually using differential equation or control system theory from electrical engineering. So evaluating alternatives can be done, in which you will be evaluating different alternatives. And now we actually advocate going for multi-criteria decision making, where for you analyze feasibility, cost, potential risk, benefit, alignment with goals, for evaluation of anything, whether that is drug or not. Earlier, we used to analyze medicine on the basis of clinical outcomes and cost only. Now we have included ethical considerations, side effect, many things are there. So now decisions have become more complex. And to solve that, you need actually basic mathematical foundation to understand that you are using the software is in right way. Otherwise, everything will be done by the software only. But you should, to level you are, right kind of input, you should be capable to be give it and analyzing the output which is coming from. The same it is possible for ChatGPT also. It's a kind of black box, but you know which type of thing you are providing the data input from, and if it is coming result, whether that is having veracity or not. The softwares are generally black box. You should understand they are working, but their input requirement, at least you should understand, and that comes from which type of data it is. And sometimes this is rooted in mathematical foundation, and for that this session is. Then you come with implementing decision in decision making. Once the choice is made, the decision need to be put into action. And these steps involve planning, organizing, resource, and executing, which is essence of actually management. And then your work doesn't stop here. Actually, you have to evaluate the outcomes, whether you can fine tune so that it is sustainable. The steps help determine whether the decision have effective in achieving the desired outcome. If it not, don't shy away. You need to modify it. Decision making is not linear. It is actually non-linear. There are feedback mechanism, which we call in control theory as a cybernetics. It happens, and of course, cybernetics is also driven by this. What you call it, a differential equation. So you need to understand certain thing. I will not be able to cover all mathematical foundation. For that, I will be going basic only, but you can build on this, and you can find out very good videos on MIT resources and many places. If you want to explore further, actually there are courses on EDX and Coursera also. You go and you try it. Those are mathematical foundation is good, so that you can build on that. Only writing paper using some software is not good idea. You try to solve real problem in industry. So what is decision science? Because decision making, then it should be science behind that. Decision science encompasses a range of quantitative techniques, utilize a guided decision making at both individual and population level. We see that in case of inferential statistics. So population level decision we make on the basis of sampling we do. It incorporates various disciplines such as decision analysis, risk analysis, cost benefit, cost economic analysis in economics, constraint optimization, which I was saying, simulation modeling, which can come from Monte Carlo simulation, or it can come from system dynamics modeling or agent bench simulation, and behavior decision science, decision tree, everything. It has some mathematics behind that, like Bayesian statistics is behind your decision tree and all. So decision science draw from field like operation research. Some of you must be aware if you are mechanical engineer or industrial engineer. Microeconomics, if you are a management background, otherwise you must have been exposed with little of microeconomics also. Statistical inferences, everyone do that these days. Inferential statistic, management control system, cognitive and social psychology is also very important in decision science, because you all actually derive some construct from different places that is almost based on psychology, and then you invent or include some other construct, and then you implement structure, equation modeling, and do this thing. So these all are done by computer science, but you need to understand the behind. At least you are saying that there is strong association. You understand correlation. Correlation also, if you are doing, you understand which type of correlation is applicable for which type of data. It is not applicable like and like always you do somewhere you need to Spearman correlation also if it is ordinal data, no? So you should understand that. So those kind of clarity should be there. Decision as a central focus of analysis, providing a distinct framework to comprehend public health issue and enhance policy development to tackle these problems. So mathematical model are very important. I will be saying that, and if more certainty is there, we can go for model equations also, but most of the cases you will be going for not deterministic but stochastic models. The probability will be involved in that. So that all will be taught to you, I guess, in this workshop, and you'll get many opportunity to learn more about that also. But this session is more about mathematical foundation. By employing decision science methodology, policymaker can gain insight into potential outcome, trade-off, uncertainty associated, different choices, and this facilitate more informed and effective decision making in any context. I'm writing is public health context because I generally work in healthcare management and public health. So this slide is for that audience. How decision science is different? While most field of research focus on producing new knowledge, decision science is uniquely concerned with making optimal choice based on available information. That's why you are understanding, going through this foundation courses and everything, so that your decision is impeccable. Decision science seeks to make plain and scientific issue that value judgment underlying the decision and identify trade-off that might accompany the particular action or action. Decision has been used in business, management, education, environment, wherever you think about military sciences, public health, and public policy. Now, it comes to your workshop, data science. What is data science? It is actually interdisciplinary field that involves extraction, analysis, interpretation, and visualization of range volume of data to gain insight and make informed decision. Believe me, data, which kind of data you are having, that is more important. If you are building your model on the basis of bogus data, it is better you use qualitative analysis. Don't go for quantitative analysis. Although quantitative analysis is very highly rated, but this phenomena is or this perception is now going down. People are now advocating qualitative analysis where exact quantitative analysis is not there. So my take is there are two type of system thinking approach in data science. One is called soft system thinking approach, where micro level decision you make for that qualitative is better. But when you gain insight on the basis of qualitative, you develop some hypothesis and you now want to test it further, then quantitative is better. That's my take. Data science encompasses various techniques and methodologies, including statistical analysis, machine learning, data mining, data visualization, whatever you call it, to extract valuable nozzle and pattern from complex data set. This specifically I'm saying pattern complex data set, because every problem is, you can think in terms of systems. Systems are formed of different elements. Like you talk about your company, there will be different departments are element. or subsystem, and then in subsystem, then every faculty will be there. That is again subsystem or element. These all are interrelated. They are interacting with each other. That relation is vaguely defined. So this all makes, and this actually relation is also evolving. The thing is, in system thinking, we call it how these all interaction is happening and how it is giving the result. That is called emergence. No. So emergence is good if the interactions are constructive, otherwise destructive. Who will measure this? Who will fine tune it? So for that, you need data science. Otherwise, to analyze it at macro level, qualitative is better. So that's my take. Maths for data science, which I will say, you should be nowadays, you should have some exposure of computer science and IT. Basically for data visualization, and another thing I always advocate till now also for statistics also R, and for machine learning and other things, I actually am in favor of Python. But if you are not good in computer programming, don't get disheartened. These all thing will become black box. You need to know only what type of data and what is your problem and which type of method you want to apply and which type of data you should actually gather. So computer science, and then maths and statistics. Maths we are discussing here already. You people have been taught about mathematics in your graduation. Statistics, of course, you will be going through, and statistics is also backbone of many machine learning techniques. And then domain and business knowledge. Here I very much I put stress on. You want to solve a problem, you should have domain knowledge. People tell me every day, why you are not doing research in automobiles? Why you have a strong background in supply chain? Why you are limited only to healthcare supply chain? Then I tell them, because I know this domain and supply chain techniques I want to use to solve problem there. So I should have the knowledge of domain. So I always advise at least become expert in one domain. That takes a lot of time. Of course, you can be an expert in 2-3 related domains. Like if you are healthcare expert, okay, of course you can, this is service industry, you can provide consultancy or research in something related field like service operations also. But the thing is, to understand healthcare, or to understand education, or to understand manufacturing, or in manufacturing also to understand automobile, these all are very much demanding. So this I give picture always. So data science is actually software development, machine learning, traditional research, and here the juncture of this intersection is data science. And that welcome to this world. Maths and statistics. Out of that, I will only discussing math. Out to that math also, I will be only discussing basic mathematics. So my job is very much cut short. What I will discuss in next 1 hour: building block and set theory of mathematics, Cartesian plane and coordinate geometry, and relation function and graphs. And graphs also I will not be able to draw here. I actually like people to challenge them to draw graphs in my class, actually, because if you love solving limit problems, you love solving making graphs, you will love mathematics actually, and calculus. So constraint optimization, unconstrained optimization is another fancy word. What for you, I'm making your life simple. When I will be talking about unconstrained optimization, generally I'm talking about maxima, minima, or calculus, differential calculus. When I'm saying constraint optimization, generally I'm saying it is linear programming, but it is not limited to that. It is more than that. Then probability, of course. So now let me go to specific. Let me start with set theory basic, and I will be little fast. Excuse me for that. Set is a structure representing an unordered collection group of 0 or more distinct object. Even 0 object is there, then also it is set. Even whenever these members are there in set, I'm saying if their membership is 1, they are completely present there, then we call it crisp set. And when there is a membership function associated with that, means partial association, then we call it a fuzzy set also. So that I will not discuss, but you should have because it started from set theory. Set theory of dot idea is there. You can build off on then on fuzzy set theory also. Set theory deal with operation between relation among statements about the set. Set theory is actually foundation of probability. Set theory is foundation of statistics. Set theory is a foundation of fuzzy soft computing, whatever you say. But set theory is very important. Basic notation of the sets, you all know that we actually write set and there are elements under curly bracket, that is ABC. Three objects are denoted by ABC. And then there can be two way, either you go for listing all element, or you go for set builder notation. All of you must be aware about that. Set builder in notation is really useful when there is infinite number of element in a set. So that's is useful. Like one example here given is x is an integer where x is greater than 0 and less than 5. So this is a finite set only having 1, 2, 3, and 4 elements are there. But if I write x is a real number between 0 and 5, then infinite number of elements are there, and then it becomes an infinite set. Sets are inherently unordered, but you can go for ordered, paired, triplet. Okay, you can. So no matter what object ABC denotes, these all, if you jumble them, all your permutation combination you are using, it is actually the same set. All elements are distinct. Unequal multiple listing makes no difference. No, if you are writing 2 times or 3 times, then also if you put it in curly bracket, it will be counted only one only. So although in this example, the last one, there are 9 elements, it will be counted as only 3 elements only. So duplication is removed. Definition of set equality. 2 sets are declared to be equal if and only if they contain exactly the same elements. Okay. In particular, it does not matter how the set is defined or denoted. No, either it is denoted as set builder form or not. The set are equal. And like this example is, for example, the set is 1, 2, 3, 4, and the same set builder form, it is written here x is an integer where x is greater than 0 and x is less than 5. Then again we are writing it as x is a positive integer whose square is 0 to 25. Basically we are saying same thing in 3 different manners, and these all set are equal. So infinite set already I have discussed with you. Set are infinite and finite without ending. And that doesn't mean one infinite set will have equal number of elements as other infinite. Infinite set may have different. So you cannot compare two infinites. No. This is the Venn diagram. We actually discuss intersection of those set using this. So there are different sets. So intersection, we can find out this set and this set has intersection as a 2. This set and this set has intersection of 1. Similarly, we can draw Venn diagram in many places where we are discussing disjoint probability, or we are calculating conditional probability also. There actually Venn diagram is very useful, and I'm going little fast. Sorry for that, because I have to reach the till probability also. Okay, so basic set relation. X is element of S is the proposition that object X is an element of a member set of X, and 2 sets are actually equality. Set equality in terms of this element relation. S is equal to T for all values of X is element of S is also for all element X is element of T. It is rather writing in a means fancy terms, but the makes sense. All values of S are same as all values of T. So basically these 2 sets are equal. 2 sets are equal if they have all the same members, the same in written in this quoted form, and the mathematical equation you see. That's why it's rather becomes intimidating sometimes, and you need to understand these notations also, because the most of the books will write in not in terms of this statement which is written here in quoted form. It will be written in a mathematical form, and I have seen many people, they use very easily this AHP, Topsys, Wyckoff, Prometheus, whatever MCDM technique if you say them. But when I say them, explain its mathematics behind them, none of them know that. It is very difficult for them to understand also, because they are not actually exposed to that way of notations, no. So you should explore, and whenever you are writing a paper in a good journal, unfortunately they are not only interested in applications, they are also interested in the mathematics behind that, no. Already it is a duplication of work, it can be found somewhere else also, and if you can do certain modification in mathematics and make the model better, no one will be you will be able to publish in Omega or European Journal of Operation Research. So that's become a dream come true, no. So think about that, and unless you have exposure of that, you will not do, no. X is not element of X. We know that the empty set is phi, we define that is the unique set that contains no element whatsoever. So phi is equal to phi is X given false, no. These are all three way are representing same thing. Okay, we have one or more. No matter the, no, we have till, okay, only half an hour, no? Yeah, we have time 1.5 hours. No matter the domain of the discourse, we have this axiom and subset and superset relation, you know. If S is subset of T, T is a superset of S. Phi is subset of all set, and the subset is itself is the subset of S. S is subset of S, not proper subset. And S is a superset of T, means T is a subset of S. So these all notation you understand. Note that S is becomes T, but both of these four, S is actually superset of T, and S is actually subset of T also. So then it becomes that both are equal. So another way it is saying the same thing, that S and T both set are equal. These slides I will share, you can go through this at your own pace, don't worry. So then there are two types of subset and superset. One is strict, when equality sign will not be there, and other is actually strict one, and proper, which we call proper also. Otherwise, it will be improper or not strict. So set are object to. When set can be object, means you can make set as an element of sets also. So the object that are element of a set may themselves be a set, like this S is equal to X is subset of 1, 2, 3, and suppose 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. These are all can be a subset of this S, no. So suppose we can form a set of all possible subset of this S, then that is also a set. We will discuss this. Coordinality and finiteness, no. S, read this coordinality of S. Almost 50% of you must be knowing this. Sometimes they write this board in set theory, sometimes the coordinality of S, and we put mod kind of sign in front of this S. It measure of how many different element S has, no. So phi has a 0 element, 1, 2, 3 will saying 3 element, AB you are saying it has 2 element, and similarly when I am talking about this 1, 2, 3, comma, curly bracket 4, 5, and how many it should be? Yeah, anyone? How many sets? How many? What is coordinality of this set? Anyone? What is coordinality of this last one? Yes. Okay. It is 2. It is not 5. No. 1, 2, 3, 4, 5 you are saying, but it is, this is actually object. So 4, 5 is 2. We say S is infinite if it is not finite. Already I have told. What are some infinite sets we have seen? Infinite set, if I say it all real number between 1 and 2, then it is infinite set. So your real number, natural number, okay. So integers you are talking about, these all are infinite set. So that's why I wrote NZR. The power set operation, the power set of a set is set of all subset of S. Already I have discussed about. So example, a set is A, B, then its power set will having one element as 5, one as A, one will be B, one will be AB. So this will be having actually 4 elements, no? So sometime we write how many elements are there in the power set. So suppose the big in the initial the subset was having 2 elements, the power set will be having 2 to the power 2 is equal to 4 elements, no? Now we are coming up to ordered and tuplets, no? And this is actually where the Cartesian coordinate system started. When to represent a point, we needed an ordered pair, x comma y, of course. So if these axes are at orthogonal, that I will discuss in your linear algebra. Don't worry about that. I will come to the axes may be orthogonal, the axes then may not be orthogonal also. But to represent a point, you need an order pair, no? Similarly, to represent certain things in a plane, if you want to represent, you will need order pair. If you want to represent in a what you say in a space, you need the order triplet. If you want to include time dimension also, then it will be actually not triplet, quadruplet. You know? There are like sets, except that duplicate matter and order makes difference. Like whenever you are doing a seating arrangement, in a cinema hall, it is an ordered arrangement, no? So you cannot replace one person with other person. So if someone is going in a cinema hall and no seat is allotted, then it is arrangement is not ordered. But when it is written that you have given a token that you have to sit on a seat, then it becomes a ordered arrangement. So this is an ordered arrangement. It is an ordered pair. So 1, 2 actually is not equal to 2, 1. Okay. So triplet, quadruplet, quintuplet, antuplet, these are very common. And if you will be doing topses, or you will be seeing that. So different alternative will form an antuplet kind of arrangement there. Cartesian product of set, for a set A, B, their Cartesian product A cross B can be written as, I'll suppose it's a comma B, and we write that A is element of A and B is element of B. So for all values, you will be saying that for A has n element, B has m element, then ordered pair, this Cartesian product will be having n into m elements. So example is given, A, B is a set, another is 1, 2. So A1, A2, B1, B2, these are the, so 4 elements. So 2 into 2, 4 elements are there. For that, if finite A, so A comma B, actually you multiplied with their, what you say, cardinal number, no? So this cardinal number have a 2, this has a cardinal number of a 2, so this becomes 2 into 2, the 4, and here this cardinal number of this A cross B, which is a Cartesian product, is actually 4. Note that it is not cumulative, no? It is not cumulative, although this cardinal number of A cross B is equal to cardinal number of B cross A. That doesn't mean A cross B is actually equal to B cross A, because it is an ordered pair. No, order A comma 1 is not equal to 1 comma A. So how can we say that A cross B is equal to B cross A? Okay, and that we will say in see in case of vector cross product also, that A cross B is not equal to B cross A, although the magnitude will be the same, maybe the direction will be different. I will come to that point also. The union operator, we have always seen in case of union, you already know. So element of A and element of B, then you will be having a union B set in which all element of A and B will be there, but we will not put even the common elements are there twice there. And so A union B in a set vector form, we write as X is element of A and X is element of B, both are there. Note that AUB contains all element of A and B. It contains all the elements of B also, no? So A union B will become a superset of A, and similarly A union B will be a superset of B also, because there is something extra than B, something extra than A, then the A union B set becomes A. And similarly, if you go for interaction, Intersection. Here some example is given, A union B union. If you are counting, so it is just it's not like A B C, then you will append it with 2 3. 2 3 can come everywhere, because here when you are representing this set, it is not a ordered arrangement. But here 2 3 5, you are saying 2 3 5, 3 5 7, here 3 element, here 3 element, 3 and 5 is common, so it doesn't becomes 2 3 5 3 5 7, it will become 2 3 5 7. Even if you write 2 3 5 3 5 7, it's not wrong. No, actually it actually means 2 3 5 7. And in mathematics, or in your life or statistics, we always advise, even in computing and programming, all to become parsimonious. No, you use minimum resources. So writing 2 3 5 3 5 7 is not a good idea. Always write 2 3 5 7. So this is required form. No, so the 3 5 was there, remove. It's very basic, so I'm skipping it. Now we come into intersection operator like that. You can also write here state builder form. A intersection B is X. X is element of A, and X is element of B also, both here. So note, A intersection B is a subset here, not superset of A and B both. So similarly, you calculate A intersection B intersection C. A, B, C intersection, this second set, which is having 2 and 3 as elements, it will be 5. If 2, 4, 6 and intersection with 3, 4, 5, then again it will be 4, because only one element is there. So here you know how to calculate already. This is very basic. So 4 was actually subset in second case. Disjointness, I will use this in probability. Two set A, B are called disjoint if their intersection is 5. The set of even integer is suppose disjoint with the set of odd integer. Nothing is common in it. So this is one cartoon is there. This is disjoint actually. No, it is disjointed, separated, most kind of. Inclusion exclusion principle is there. How many elements are in there A union B? So you can easily calculate A union B. Number of A union B is equal to number of A plus number of B minus number of A intersection B. So either you put this cardinality sign, or you just write number of A, number of B, then it will become this equation. So you can easily calculate A union B. And similarly for intersection also, you can do the similar manner. So here also intersection B, you just keep it on this. This you bring on right hand side, and A plus B minus A union B will become A intersection B. So it's very easy. Then we talk about set difference. The set A and B is the difference of A and B written as A minus B. It's the set of all elements that are in A but not in B. No. So we say that X is element of B and X is not element. X is element of A, but X is not element of B. So the complement of B with respect to A is called A minus B. So difference, suppose you want to calculate, you can easily find out. So A minus B, if you are doing that, it will be here 1, 2, 3, 4, 5, and 6, and here 2, 3, 7, 9, and 11. If you want to subtract these two, how you'll be doing that? So this is actually 2 to 2 is gone, 3 to 3 gone, 5 to 5 gone, and 1 is remaining, 4 is remaining, 6 is remaining, and you got 1, 4, 6. Nothing to do with 7, 9, 11. That's we see. It's not like you write then minus 7, minus 9, minus 11. That is actually wrong. Similarly, if there are numbers, no, of positive and negative, there are numbers, and then there is a real number, and then you are subtracting it, you will get certain numbers. Set difference by Venn diagram, you are saying A minus B is what is left after B takes a bite out of A. So this is set A, this is set B, and this B is taking this bite out of that, then the set A minus B remains like this. Okay. So this person, this shark has eaten that portion of this. So this is A minus B. Complement, already you know the universe of discourse can itself be considered a set called U, and The complement of A is written as complement of set A complement. And so anything is part of universal set, which is not part of A, is actually complement of it, this. So generally, UN will say that A union A complement, that becomes universe, no? So that's this complement, you know already, this is A, and whatever there is A complement, and if you just join these two, it becomes a union set, you know. Identities, if you say, before I move to, because I'm running out of time, 1:45 already. A union phi is A union, A intersection union is A. A union you will do, you will find U, A intersection phi, you'll say phi. So these are dominated. Idempotent, idempotent actually. A union is A, intersection A is also A. Double complement, if you do, you'll get the same. Cumulative is A union B is actually B union A. Intersection B is equal to B intersection A. Associative also similarly, A union B union C is actually A union B union C, and similarly for intersection. So these are certain set identities. De Morgan's law, very useful certain times in many data science application. So A union B, you take complement, you'll get A intersection B complement. No, A complement, intersection B complement. Similarly, A intersection B, you take complement, you will get A complement, union B complement. Generalized union, it you will see many times in your statistics and even other data science or decision science, of course, methods. So A union, A1 union, A2 union, AN, actually you put bracket anywhere. That just means grouping order is irrelevant in that, no? How you write it, you'll see somewhere big U, like sigma we say in case of summation, I equal to 1 to n AI. And if it is infinite, then you cannot write actually I equal to 1 to n. You cannot count, then you're like A is element of X and U A. So this is generalized union. Similarly, generalized intersection also, again, grouping is irrelevant there. Here we will write big arc, no? There big U and here big arc. And similarly, if it is finite, I will write I equal to 1 to n AI. And if it is infinite, I will write A is element of X, intersection A. So these are certain things. And with this, I come close to this set theory. If you have any question, you can ask. Otherwise, I will move to unconstrained optimization. Now, let me ask you certain questions. Are you able to grasp it, or it was too fast? Then accordingly, I can make slow also. Anyone? Are you able to hear me? Hello.
Yes, sir.
Able to hear me?
Yes, yes. We are understanding, so sir. Okay.
Okay. I'm little fast, and because we have very little time and we have to cover all basic fundamentals. Okay. So unconstrained optimization, one where you only have to be concerned with objective function. You are trying to optimize. Don't think about the other constraint. No, like sometime in your life, you will be asked to do certain things, and like you will be asked to get admission in best of the best college. So that is your objective function. I wanted to take admission in MIT. No, I got admission also in Texas. No, but the thing was, then constraint is you should get 100% scholarship also. That was criteria 22 years back. Now I was not having, there was 75% scholarship and something. So 25% from where it will come. So that becomes a constraint. So here I'm saying unconstrained optimization problem is one where you only have to be concerned with objective function you are trying to optimize. But in real life, actually, that's not the case. No. And okay. An objective function is function that you are trying to optimize. So like in my case, it was getting admission in good university. That was, then constraint was money, constraint may be location, constraint may be visa, many things, no? None of the variable in objective function are constant in that. It can take any value, no? So the time I say that my fee should be only this, the constant I'm putting, this many colleges comes actually become many students I have seen them to apply after CAT examination for MBA colleges, and then constant come that they cannot afford fees of 18 lakhs, no, 19 lakhs, and they will be not getting certain loan because their father is not working. So their job is cut short. They are now left with only universities where actually which is in university systems like BHU, AMU is there, Kurukshetra University is there, in South Bhartiya University is there, Anna University is there, GNU is there. So because they can provide at affordable price the education. So that's the thing. Even they cannot afford. So maximization fx is equivalent to actually minimization of minus fx. So this is called a duality principle in not only constant optimization, but in unconstant optimization, but also in constant optimization. So maximization, we generally go for profit we want to maximize in life, real life productivity we want to maximize. Minimization, generally we go for cost we minimize, stress we minimize. In case of even motors you are mounting on certain surface, you will try to minimize the vibration, of course, if you are engineer. There are many things, no? So you model also. So when I was guiding one PhD from steel industry, there one more concern was that using experiment, Tauchi experiment also. I told them model it using regression only if you are doing that. So in which case actually the vibration is less. That was one concern. So think about that in line. This is maximum. Suppose you are doing this curves very simple. It is fx is equal to minus x square plus 8x it is. And here you are seeing that the maximization is here only. Now, if I'm saying this x is between 0 to 3 only, so my maxima will shift from here to here. So the time you actually shifted from unconstant to constant, your answer will shift. So that is called compromise actually in your life or in engineering design, whatever you say, that you will not be having an environment when you can optimize for this unconstant optimization. What is the sign of f dash x? So what you do in case of unconstant optimization, you generally differentiate it and equate it with the function will be there where independent variable will be fx, dependent variable will be fx, independent variable will be x. Okay. There may be one variable, there may be two variables, then there are different method for that. But simply thinking simple, only one variable is there which is x, and then you can be able to represent in terms of equation there, no? So you have written it, then you differentiate it fx with respect to x, equate it to 0, find out roots, and then again you double differentiate it, and if the f double x is actually less than 0, then you say that it's you have reached maxima, and or similarly you have reached minima. So so what is sign of f dash x when x is greater than x star? What is sign when x is equal to x star? A point x star where actually f dash x was 0 is said to be a critical point. This is the first order condition of x star to be a maximum and minimum. Then second order condition is this x star, the critical point of fx, can be decided whether it's a maximum or minimum or neither also it's possible. Yes. So examine the second derivatives. Now this x star, the critical point is maximum when this f double dash x is less than 0. It is minimum when f double dash x is actually greater than 0. X star can be maximum, minimum, or neither. It can be a point of inflection also if f double dash x is equal to 0. It's also possible, no? So you think about that. Example of f double dash x is equal to 0 here, where it is 0. So suppose fy is equal to fx is equal to x cube, where f dash is equal to 3x square, f double dash is equal to 6x. It implies that x critical is equal to 0, f double s is 0 is equal to 0, this point 0 is a point of inflection. So it's called also saddle point, where point is neither maximum nor a minimum. Is so you can do that. I will not go into problem, but this is first and second order condition you are employing, and basically you are finding out maxima and minima. And this is actually it's not that simple. There are many concept of global maxima, global minima, also local maxima, local minima also. The thing is, the basic point I want to convey here is unconstrained optimization can be done using calculus, and we do that, and it is very much in done also in unconstrained optimization. Also maxima minima also can be utilized for constraint optimization. When you are defining my x can vary from where to where, there local maxima, local minima type of concept you are giving. But in real life, generally we go for means some complex problem where it is not so easy to be solved using calculus only. So we use linear programming, that I will discuss. And if time would have permit, you all actually can do solve using simplex method, or even simplex method I used to teach in my class, but now I don't teach actually, because that is not required for a management professional. Because you can solve this using Excel very easily. Then why needed actually? But of course, for teachers like us, actually we should understand what is simplex method also. And of course, to students, depending on their extent, we can give them exposure about that. So maximum minima already covered. So unconstrained optimization it was. Now I will move to constraint optimization. No. So constraint optimization we will discuss with examples certain, and it is actually you can do that. So model formulation, how you can find out graphical solution method. It is generally taught in case of management colleges in their project management classes or operation research. They teach this graphical solution method, but hardly required these days. Everyone is using this Excel to solve this linear programming problem, even difficult. Mix integer learning programming also. Integer learning programming also they can easily do using this Excel. And extensively this linear programming using Excel is being utilized in classes of supply chain of MIT. They use it extensively, and they even take examination also for their students on solving location problems, solving vehicle routing problem using Excel. They tell them to do that. And even I also, when I was working in a management college in Delhi, I used to take two examinations. One examination was basically theoretical midterm examination, or end term examination I used to take on Excel only, where they will be doing this what you say statistics, where they will be using their linear programming, and even some level of what you say unconstrained optimization or Wolfram Alpha you can use for that. You can give a student access to, if that is proctored examination. And I used to ask them to submit their Excel for evaluation. So that gives a flavor of data science in students actually. So because they know that they have to apply in their classes if they want to pass the examination. So that will put them up, means positive pressure on them to use this tool in their project work. But don't ask them directly to an examination by giving one example. Give them projects also where they can apply linear programming, where they can apply actually set theory or the fuzzy set theory in their project work, and they have certain command, and they can actually use that in end semester examination or end term examination also. And the project work and the end term examination weightage should be such that the student don't fail. Because some of your students in management, if you are not engineering, will be not good in mathematics. That doesn't mean they are good bad student. They should be evaluated that for their understanding at least, not only for the solving, whether they were able to get optimum solution solving a linear programming also or not. But it is very easy. Most of the case, I give a simple program, not very difficult assignment problem or uh, transport problem or traveling salesman problem. I give them and they are able to do that. So linear programming is, that's why, very important, not only for us to solve our to apply in our research work. Of course, if you are applying traveling salesman problem these days in your research paper, no one is going to publish that. They need something else. So for that, you need to develop complex model, because the real problem you want to solve, that should be through optimization model, which is actually close to realistic. No, close to realistic things are complex. But luckily for you, there are tools which can be used, like Groby is there, and based on Python, you can use that even for supply chain network design, where linear programming we used to apply. There is any logistics and many tools are there. You never know that the basic maths behind that what it is, but when you are teaching your students, you should give them a simple flavor of linear programming, although they will be using that. So even you are not exposing them on Lingo or SAS, at least give them some exposure of Excel and tell them to solve linear programming problem in their class, operation research, and even this supply chain, and even finance also, decision making, even economics also, economics analysis. Even if you are in engineering, there are subjects like engineering economics, where we use actually linear programming, goal programming is used. So, but you need to build upon that. And if you find that your student will be having difficult and they will fail, but then you evaluate them on these tools and mathematical concept in their project works, not in this formative assignment or in-term examination. So that's my suggestion. Linear programming is a model consisting of linear relationship representing a form, objective, and resource constraint. The beauty of Excel is you can go for non-linear objective function also. So if they understand linear programming, they can build non-linear objective function, which is in case of finance many times required in financial engineering, and they can use that because this looks like same. No, only you need now to select simplex method in Excel. You have to select ARG non-linear. There is an option given, and you can easily apply. They will never know that what happened, but actually mathematics behind that was very tough. So the thing is, even basic understanding of mathematics enables them to solve realistic problem which are non-linear in what you say relationship. But of course, to start with, you should give them exposure of linear programming. So LP is a mathematical modeling technique used to determine the level of operational activity in order to achieve an objective subject to restriction called constraint. And of course, this calculus, which we did maxima and minima, that was also mathematical modeling technique. And of course, in that case, the constraint was less. But saying that constraints was not there is not also not right term, because there also you introduce local and global maxima minima concept. There is also some constraint we actually apply. Types of linear programming models which we use in actually operation management, because I have taught operation management for many years. Aggregate production planning determines the resource capacity needed to meet demand over an immediate time horizon. Product mix planning you can do in case of production, also in case of marketing, also transportation and transshipment problem, of course I do in case of supply chain. Again, the thing is, operation research subject are taught which are disjoint with supply chain class. No, so generally operation research um, you apply, but there you may be different in opinion from me. Operation research subject are taught first, and then supply chain and other subject are taught. Students don't know why they are using these things, no, but if you give them a region, this is the result you will get because of that. So of course, giving them a certain glimpse that supply chain, these are the use of these techniques, and that's why you are doing, they will be more interested in mathematical foundation of the course. So assignment problem, multi-period scheduling problem you can do using linear programming, blend, diet planning you can do in case of hospital. That is very much interest of for me menu, because in case of see, two things are there. Diet, no one has thought like that, because but I, in my research paper, I'm doing that. And see here, even simple linear programming planning, if you are applying in some different problem in different area, your paper will be published. See, the calorie intake is actually you want to minimize, but at the same time you want to provide certain kind of diet, lunch, dinner, and something. And at the same time you want that person to be satisfied, also satiety level means his stomach is also not empty. So this becomes actually linear programming problem of minimization of calorie actually. And the nutrients also you cannot means minimize, be certain should be there. So think about the plate concept of your diet. There should be certain amount of protein, certain amount of roughage, certain of carbohydrate, and the same time total calories should be less than suppose 12,000 kilocalorie if a person is diabetic. So this is actually a linear programming problem. And this I actually was able to teach my public health student that use it linear programming. And because this Excel was so easy for them, they only defined it and they were able to run, they were very happy. Um, but before that, I explain them the basic concept of linear programming, what is objective function, what is constant and unconstrained optimization, and they feel very happy. Engineer you are, of course, in future, your triple IT also, these all will come up with medical courses. You should be prepared with this. You should learn the art of teaching mathematics to even public health and medical professionals also. It should be that simple that they never come to know. It should be that robust that they don't commit error. That should be your objective. Investing and capital budgeting, of course, you have if gone through DEA principle, data element analysis, and of course, efficient frontier. If any one of you are having financial background, you must be knowing that how we draw efficient frontier in case of investment. So there also linear programming applications are there. DA already I was doing efficient frontier of a company, shortest route, traveling salesman problem, maximum fraud, trim loss, facility location already I use in case of hospital management, and set covering, selection of facility that can service a set of other facilities also. So that I used in case of my PhD thesis, set covering and all. So these are certain applications. You see that simple linear programming, and you need not to use go into simplex method for solving this problem. You should only understand this is constant optimization. I will go for an optimum solution. Even if the problem is very difficult, I'm running using Groby. Maybe if I'm running it for hours and hours, maybe I will not reach to optimum solution. Then I can set a time limit that after 10 hours, whatever the solution I will be getting, that will be my feasible solution, and I will accept that. So that's also good. So LP model formulation, decision variables will be there, mathematical symbol representing level of activity of an operation. There will be always one objective function like cost is there, like things are there. And then there is a linear relationship reflecting the objective on an operation, most frequent objective. How many hours are left? And can I know it? Accordingly, I will paste the. It is. Is there anyone? Okay. Let me check. So that's the case. Okay, 1 hour is there for me. So it is sufficient. I will be able to cover everything. So in LP model, even we will be taking 5-10 minute break also if you want. That's also possible for me. Or we will try to close it by 4:20 because I have meeting. So we can do that also. So decision variables are mathematical symbol representing level of activity of an operation. Objective function is a linear relationship reflecting the object of the operation. It is in case of linear programming. If it is non-linear, it may be parabolic relationship or any kind of relationship. If an exponential relationship between decision variable and objective function is fine. Most frequent objective function of business firm is to maximize profit because everyone is interested in that, but that's not the case. No. So that's why we go for goal programming and many things are there. Like always our objective is not to maximize profit. Our objective is, in the case of at least healthcare, to maximize profit, to minimize the risk to patient, to minimize the infection. Many things are there. To minimize the life lost, no? To maximize economics, we discussed about maximize the social welfare also. So most frequent objective of the individual operational units, such as the production or packaging department, is to minimize cost. So generally in engineering, we are maximizing profit, minimizing cost, but this is not only limited, it's too simplistic. In life, there are more than one objective. We can think about, so extension is goal programming also we do. We have multiple goal, lexicograph method we follow there. Constraint are a linear relationship representing a restriction on decision making. No. So LP formulation may look like this: maxima or minimize, you are doing Z is equal to C1x1 plus C2x2 plus so on Cn x1, subject to many condition. This x1 linear combination of these things is less than or equal to some value b1. And there's similarly the other, there may be many. So there here m constants are there. There is one objective function which is linear. Your constants are also linear, and your objective function is also linear. That is why it is called linear programming model. So xj is equal to decision variable, and bj is constant level here, b1, b2. So b1 are this constant level, and actually this ci, c1, c2, cn, these all are actually objective function coefficient, and this aij are constant coefficient. So this way you can actually write your LP model formulation. But the thing is, generally what happens, generally why our solution is, suppose you will be including more constant, the chances is your optimum value will be, if you are maximizing, it will be less, or you are minimizing, it will be more. So to solve that problem, actually you should actually supply what are the constraints, and it is nothing to do with mathematics. Actually, it is everything to do with understanding the problem well. So first you understand the problem, what you want to maximize or minimize. Then there are like constant you write, and then you define the constants levels and everything, you write that. It's not that simple in real life. Even these variable decision variables are not that crisp. They can take values which are non-crisp. So we go for fuzzy linear programming model formulations also. So you can use that in your research work for papers. But for teaching, this is sufficient for graduate teaching, postgraduate teaching also, but not for PhD. LP model examples, suppose we are having this resource requirement, very simple program example I'm giving, that doesn't mean in your class you will be having teaching you can use, of course, but in assignment, the student can explore a difficult problem. So products are ball or mug you can make. Resource requirement for ball is 1 unit, for flavor, clay 4 unit, revenue it is coming from ball is 40, for mug it is coming 50, and liver and clay is 2 and 5. there are 40 hours of labor and 120 pound of clay available each day. So that is boundary. So decision variable is x1, how many of ball you'll make, and x2 is number of mugs to produce. So this is the thing. Now, here, what you want to maximize here, you can think about maximizing revenue, or you can also think about if your selling value is fixed, sales price is fixed, you can think about minimizing the cost. So, of course, your contribution will be maximized, means sales price minus the cost. That is called contribution in business. So the same problem, if you are subtracting it from there, this problem of maximization can be changed into minimization problem. No, so that is called duality. So LP formulation example, minimize this Z, which is objective function, which is revenue here. $40 x1 plus 50 x2 subject to this x1 plus 2 x2 is less than, because in x1 you are taking 1 hour, for x2 in case of ball, for mug you are taking 2 hour, and this hour, and this is less than 40 hour labor constant. And similarly clay constant is there, 4 you are taking for ball, 3 you are taking for mug, and the sum is less than or equal to 120 lb. So clay constant is here, and now this is called non-negativity constant. It means x1 x2 cannot be negative, otherwise it will make it negative, and then your value will be becoming something like negative x1 or x2 you'll get, which is of no use. No, so this way you can say that when you'll solve this, you will get x1 is equal to 24 ball, x2 is equal to 8 mug, and revenue will come $1360. We'll try to solve it using graphical method for only for introduction. We will see the same problem using Excel also, and it is very easy to do. So graphical solution method is actually plot model constant on a set of coordinates in a plane. Identify the feasible solution space for the graph where all constraints are satisfied simultaneously. I will be discussing this for maximum problem also, minimum problem also. Plot objective function to find the point on the boundary of this space and maximize or minimize value of the objective function. See how it is happening. Graphical solution, this was actually one of your constraint. X1 plus 2 x2 is less than 40 hour. That was man hour labor constraint. This was 4x1 plus 3x2 is less than or equal to 120 lb. This was clay constraint. And this, if you take intersection, so this area common to both constraint is here. So area common to both constraint is here. This is your feasible range. Now, your solution can, here 3 edges are there. One is here, one is here, and one is here. Your solution can exist either here or here or here. So you put these 3 values, which is actually 0, 20, and we will solve and we'll get what is this value, and this is 30, 0 in your objective function, and check which of these value is actually giving you maximum value, and that will be your solution. So so you move it to here. This is your objective function. No, you move it here. It is you move it to here. This is your objective function. So you are moving it to here, and now what is happening? So you actually found this point as x1 is equal to 24, and you put that value here, and x2 is equal to 8. You are solving these 2 lines and you are getting it x2 is equal to 8, x1 is equal to 24, and when you are putting it in objective function, your value you are getting is 1360. No, so this example I have taken from Wiley book, and the supplement of that. I will say this slide. Extreme corner points are here, here, and here. These 3 places the solution can come. So here x1 is equal to 0, x2 is equal to 20 mug, and the revenue is coming as $100. Similarly, from here it is x1 is equal to 224 balls, x2 is equal to 8 mugs. Your value is coming as 1360, and now here x1 is 30 and x2 is equal to 0, and your z is coming 1200. So that doesn't means only here the maximum point will exist. It can exist here, 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 but the thing is this is a convex frontier kind of, and the edges you can explore. You need not to go for these all infinite point, these all infinite point, and you'll get solution. So this is easy for you. This you got z is equal to 136, but this need to solve and actually plot also. Now this is another objective function. If it is 70x1 and 20x2, where constant is equal to 4x1 plus 3x2 is less than 120 lb, and x1 plus 2x2 is equal to 70 hours. The objective function we have changed. So now this is the objective function C. No, now what I'm doing is shifting here, and in that case the value what is coming, and here we are saying in value what is coming. So here value is coming 2100. Here the value is coming less, and here with the value coming less. So changing the objective function actually, and constant are same, your optimal point changes actually. So need not, so it's not like that objective function will change. So it's actually depending on your input cost in production and everything, actually your optimum point may change if the constant are same there only. So this is one of the learning from here. Now similarly, minimization problem, if you are saying here two brands are there, Grow Plus and Crop Fast, and their contribution of chemical is in one there is nitrogen, and other there is phosphate. Is these brands are related to fertilizer side. And this Grow Plus, the nitrogen is 2 lb per bag, and phosphate is 4 lb per bag, and Crop Fast it is 4 lb per bag, and phosphate it is 3 lb per bag. So actually you are minimizing the cost. So minimize Z so that 6x1 plus 3x2 is your objective function. And at the same time means x1 means cost to produce this x1 is actually 6 unit, to cost to produce x2 is actually 3 unit. These two are decision variables here. Now subject to 2x1 plus 4x2 means nitrogen is it should be used at least 16 lb of nitrogen you should use. Maybe there will be constraint from supplier side that they will be not supplying nitrogen less than 16 lb. So you should think about that. Constraint comes from actual real business problems, not comes from somewhere in heaven. 4x1 plus 3x2 is greater than or equal to 24 lb. Here phosphate also you need to use, which is 24 lb. Non-negativity constant is x1 and x2. So this is a problem of minimization. Now here the same way you have solved these two constraints, and this constraint C, the common point is here, and this time it is not convex, this is a concave frontier. And this, in case of minimization problem, this becomes your feasible region, not this like earlier when it was maximization. Now your solution will exist on this point, or in this point, or in this points, not like this points, this point, and this point, as it was in case of maximization problem. Okay, understood? Now see, this is my objective function. I'm moving it here. So it my cost is 24. Similarly, I will move to some other place, the cost will be different. Some other place, the cost will be different. So depending on that, I can find out which is giving the minimum cost, and my solution is, in this case, is Z is equal to 24. That means when I'm putting this value, it will come greater than 24. When I will come to this point, it will come. See, just put the value here. It is 0, 8, 0, and you're putting here it will become 48 Z, or 3 into 0. So here this is not, similarly this will not be, and that's why this is the point, optimal point. So always understand there is a difference between optimal point and feasible point. Sometimes even this problems looks very simple as solved very small time. When you will be formulating problem in SAS and Groby, it will take hours of time, maybe 1 day, 2 day. Then you can fix constant that I want to stop this calculation after this many of hours. No. So suppose simple thing, I'm saying many constraints are there, then you are forming this, then these points will not be 1, 2, 3, 4. It may be in hundreds and 200. And if you are solving for each and every point, it's going to take a lot of time. No, so you can think about in that case of also graphical solution also. If I have only 15-20 minutes, then you'll check randomly certain points, and if you are finding and your constraint was there that I need not to spend more than $50. So suppose some solution are giving you options 70, 50, 80, something like that, and one solution gave you $49. You'll select that and you'll close the program. That is the approach we generally do. Whenever we go in market to search certain things, we never get optimal solution, optimal price for our product. But we have a budget. Budget is a constant that we say that if I will get it in $50, I will take it. And we do that, and become, then real life problems are never optimal. These are having the constraints. So even in case of linear programming also, you can put further constraint, which is of time. So even you are doing the calculation, you can say that after this many iteration, after this much time, you stop there. So that is the so this is LP in Excel. You can do easily. You can formulate your problem. Profit is equal to this, which will be actually product of and here in solving LP problem, always initiate your decision variable with 0, 0, no, because and then you'll be formulating your linear programming objective function, it will come 0. That is a check also, no, that you have created your objective function in right fashion. From 0, you will then run it, the program, then the 0 will be changed to certain other value depending on their means optimization run, and then that will be the value, and the profit or cost, whatever coming, will be accordingly. So so see here, this is let me do the same problem. I know you people have already done, but for the people who have not done it, so I will be taking up this very basic problem, but that doesn't mean, or you can do one thing, because we have less time. The same problem I have included here. You need to install solver in there, and then you can use this solver parameters you can define, and then you can run. And so see, like initially the values were something, your non-zero values were there, but I generally take here slack variables are also there left over, and this concept I am not going to teach today. But see here, this production gives you the decision variable value 24 and 8, and profit was 1360, which we got from this graphical solution also. But if it is a see, if it is very easy, the graphical solution also you can do, look simple. But if it's little difficult, you can go for simplex. But it is far difficult, it's become very difficult to solve using simplex method also. Then what to do? That's why I always suggest, don't go for graphical only for demonstration. You can use, don't go for even simplex method to your student, they will lose interest. Even engineering student will be able to solve simplex method and everything. For management professional, mostly you go by solver, and they will find it very useful and application, and they will take this with them home, and they will use this in the industry also. Sensitivity analysis, which we can perform in case of linear programming. If you are making small changes in your decision variable, whether your decision is changing or it is robust, that kind of things also you can do in your research work to make it more robust. And that's idea from my side. And the sensitivity range for ball, the same problem, I have tried to include it here also. So the slide will be with you, you can do that. And okay, now next 20 minutes are there, and let's see what is left, right? Left actually. Two things are left: probability theory and linear algebra. Okay. So no problem. I will start with linear algebra mostly, and no, probability theory, and then linear algebra. So let's go through this, and slides are available. That's I wanted to demonstrate on this also. Okay, these are 57 slides.
Sorry to disturb you, sir. We can we start with the linear algebra? We are already having
Yeah.
this session on the
Yes,
probability. So
probability
you just
must
take
be,
the
yeah, in the statistics, no? They will
yes.
teach. Yeah, we can skip this because time is also not there.
Yes.
Slides I will share if you want, no? Anyone want to use? Basically, conditional probability is there, and probability rule of sum rule, and there are some problems also there. You can use that. Let me go to linear algebra. So linear algebra we'll be discussing. This is the faculty you should follow, and this is Gilbert Strang. He is from MIT. He actually says that this linear algebra has become very important in case of decision making and data science. So you should at least understand the basic of linear algebra. You know, even you people are engineer, you better know these things. But when you want to convey it to management people or industry, when you are doing MDP, it becomes very difficult. There are two reasons behind that. First, you people talk in terms of very jargons, no? Like differentiation also, you are saying vector calculus, you will be starting talking in terms of divergence, curl. You will be transmission losses also, electrical engineer is there, they will be talking like that. So these things actually industry people don't understand, and that becomes a very big problem. I was discussing with one person with PwC, he is in the same type of consultancy. Actually, you make it very simple to understand for a customer, but when you are doing application, you make it robust for you, means preparing reports. So you put all those information in appendix, but in your actual report, it should be very lucid and very simple. So that's my idea. So this is a gentle introduction, and this Gilbert Strang has a course on MIT about this linear algebra. And not only I'm saying math foundation, if you go and this Gilbert Strang actually teach there in MIT, his courses, you'll find out, at least you can find out open, what you say, archive of those courses, and you can get idea from there, what actually they are teaching. And why they are teaching, that's very much clear, because it is required. So this is vector, and think of a vector is a directed line segment in n dimension, has a length as well as direction. So vector we will write as a B, C, and it is different from scalar. All of you know. Basic idea: convert geometry in higher dimension into algebra. Actually, it started like that also. We were having algebra, we were having geometry, no? And the problem was there, this geometry people, the Greek people were very good in geometry, but they were very astute also. They also knew how to teach these things to people who are not good in mathematics also. And the first thing came into picture was trigonometry, Trigonometry came into picture, and then actually they combined this geometry with algebra, and then coordinate geometry came into picture. Coordinate geometry further, then evolution happened, and then calculus, and then vector algebra came into picture. So the thing is, this things abstraction was the art, means what is happening? You are making it simple actually. Sometimes what happens, vector algebra looks very difficult, but it is required. So I will only be discussing the basic, but of course, if you have interest, we can discuss linear algebra personally also if you have any problem, but most of you are engineer, so you can do it on your own notes. Basic idea, convert geometry into higher dimension into algebra. Okay, so geometry, you are converting in using algebra. Once you define a nice basis actually, basis, this term is very important, linear, along each dimension, x, y, z, then you can represent our vector into. Vector becomes n into 1 matrix. So here 3 into 1 matrix it is. And when you transpose it, it will become A, B, C. Geometry start to become linear algebra on vector like V. So geometry will be actually represented in count of this matrix, and then it becomes a linear algebra like that. Vector addition, you do A and B. If you want to add, you will be adding x1, x2, y1, y2, and this will become x1 plus y1, comma, x2, y2. So A plus B is equal to C, and generally it is taught in our physics also, in mathematics also, in class 11th or 9th. Use the head-to-head and tell method to combine vectors. A scalar product, you already know. I will not spend much time. A into B, it will, all elements will be multiplied. So this was the vector. Now the magnitude will increase, direction will remain same. This changes only length, but keep direction fixed. This matrix operation AV can change length, direction, and also dimensionality. So it's not like when you are saying this is scalar and we multiply it with vector, it is only changing magnitude, not it is changing the length and no, it's only changing length, not direction and dimensionality. But when you multiply with a matrix, which is another vector, it can change both, or length, direction, and also dimensionality, which we will see that. So when we say the dot product, already we do that dot product, vector magnitude of A, magnitude of B into cos theta, where theta is angle between these two when you are putting tail together. But then in case of vector algebra, linear algebra, we write A dot B is equal to A transpose multiplied with B, where this A matrix was transpose, so it was A, B, C in vertical form is become horizontal A, B, C, and D, E, F, and you are multiplying this, you are getting A, D, B, E, and C, F sum. So it's kind of dot product can be written as a matrix multiplication where A transpose B is there. Now we write this same A square matrix is actually A transpose into A, and A, B, B, C, C. This is not rocket science, you can easily understand. And already we have studied in physics or in engineering mechanics also in first year of engineering. A, B is actually magnitude of A, magnitude of B, cos theta. The dot product is also related to the angle between two vector. This is theta and this is cos. So this is not rocket science. Inner product we call it, or dot product. So U, W actually will become transpose of W multiplied with V vector. So V into W you are saying, and then this is actually x1, x2. If it is transport, W is transport, and this is y1, y2, then you're getting x1, y1 plus x2, y2. If vector U, V are columns, then the dot product will be, actually both are column, then dot product will be the transpose of this multiplied with V. The inner product or dot product, whatever you say, the result is always scalar. So this is called also a scalar product. V dot W is written as, when you're saying dot product, it is written sometime like magnitude of V and W into cos alpha, where alpha, it is denoted here is angle between V and W. So if, of course, this alpha will be 90 degree, then it will be 0. These vectors are orthogonal, are perpendicular to each other. So it's not a rocket science. Projection, when we were talking about in case of engineering drawing or anywhere we do actually in architecture, they actually apply these things. This X is a vector and A is a vector. You are taking the projection of X on A, that will be defined as actually X transpose T into multiplication of A. So this can be done. And here the A will be having magnitude of 1. So you can get easily the projection of vector X on projectant on A. So basis and orthonormal basis, which we saw, basis or axes in Cartesian system, we call that. These are actually frame of references to represent a vector. The thing is, in real world or real problem you are solving, these vectors, these diagonals are not orthogonals. So orthonormals, actually, when we are taught to for that, the angle between these bases can be a big angle which is not 90° also. But to make things simple, and so that the dot product is 0 or projection on one axis on another is 0, we go for this Cartesian system kind of things. Okay, so basis, a space is totally defined as a set of vector. Any point in linear combination of the bases, any vector can be written as a linear combination of the basis, which we teach in case of linear algebra. Orthonormal is actually nothing but orthogonal plus normal. So suppose we are having three vectors X, Y, and Z as space bases or axes. So one is 1, 0, 0, other is 0, 1, 0, third one is 0, 0, 1. And these are orthogonal, normal, these are. So if their dot product will be actually 0, so or a scalar product or inner product will be 0. And their magnitude here will be 1. So if you are taking means projection, the condition was there that the magnitude should be 1 on the vector on which or basis on which you are taking projection. So this is the thing. Now, what is a matrix then? And here you were saying that these all were vector, and if the dimension is n into 1 or 1 into n, then you are saying either a column vector or row vector. Now, when there is this number of row, number of column, both are not equal to 1, both are other than 1, then it becomes a matrix, a set of element organized into 2 column and 2 rows. So this is the thing. Addition, subtraction, multiplication, creating new matrices or function. So you can, if you are adding those two matrices, you can easily do just add numbers. If you're subtracting, you can do just subtract element. If you are doing multiplication, then it is a little tricky. Here you have to multiply AE and plus BG, and then AF plus FH here, then CE plus DG plus CF plus FDF. You better know to multiply this. Matrix times, when you are doing it is as then more order is there. So suppose here 3 into 3 matrix is there. So you can think about how to do that. Only one example I'm giving is L12, if it is multiplication of these two, is actually multiplication of this row and this column. So corresponding this element multiplied with this with this will be multiplied, and sum will be there. That will form L12. Similarly, there will be 9 other calculation, and then you'll get L. So this is the thing. Multiplication is AB equal to BA. That is general confusion, and the answer is may be or may not be. When it will be and when not be, I will discuss it. Matrix multiplication AB applied, transformation B first, and then again transform using A. See how it is happening. So AB is not equal to BA, so multiplication is not actually commutative. If A and B both represent either pure rotation or scaling, they can be interchanged. Then in that case only AB equal to BA. So that is one property. Matrix of operating on vector. Matrix is like a function. Sometimes we say that. So generally in transformation of axes you do in case of vector operations. Many times like subsidy you are giving one matrix is there for different variables related to economics. So one subsidy matrix will go that will transform the outputs or different elements of matrix into different matrix. So that type of operation is possible. Matrix like function and transform the vector on a plane. Matrix operating on a general point transform x and y component. System of linear equation actually happens. Matrix is just the bunch of this coefficient. So suppose here a, b, and c, d is there. This is a function on this x, y. Suppose I was saying the income of the person x, income of the person y, and this is a subsidy function or government initiative or government incentive or government taxation. These are certain things. If you multiply it on this, it becomes x star, y star. So this earning or saving or whatever were defined in this basic axis got transformed because of this government policies. So it is possible, and this matrix actually is like a function that transforms this vector on a plane. So think in that direction also. Inverse of a matrix, if it is identity matrix, then A multiplied by identity matrix becomes A only. That's we all know. Inverse exists only for a square matrix, not for all matrix actually. So matrices that are not singular, which is having determinant is not equal to 0. For that, inverse is possible. And this maps actually into ND space to another ND space bijectively. I will see some matrices have an inverse so that if they are having, which is having they are non-singular, they are square, then only they will be having inverse. And in that case, A into A inverse is equal to identity matrix happens. Inversion is little tricky. Actually, if you want to multiply 3 matrices and then taking inversion, actually it is actually in reverse order. Then C inversion, then B inversion, then A inversion, you multiply, then you'll be getting derived from this cumulative property. This is one property of inverse. Determinant of matrix, I told you, is simple. For 2 into 2 matrix, you can calculate it using like this. And if it is there, this is a simple matrix, square matrix. We can, if this is not equal to 0, determinant of A not 0, this is non-singularity. In that case, we can calculate A inverse, and that will be given by the changing, like A and D, you are changing, D and A making, and B and C sign you are changing, minus you are doing, and dividing it by the determinant of A, you will be getting actually inverse. So this is very basic actually. It's not that simple, but you can find out inverse of a square matrix if the singularity is not there. Transpose of a matrix, you know already, AT is transpose of A, B, so that on the rows you are converting into columns you are converting into row. It's a very application in inverse calculation and other things also. So orthonormal matrix, for orthonormal matrix, one property is there that A inverse is actually A transpose, no? So that is the thing, how to calculate transpose, keep the orthogonal, but reflect all other elements from diagonal. So you change Aij to Aji, where I is the row and J is the column, then it will become transpose. So this is one thumb rule which we do. Now this, when I was saying that this vector product, so vector product is of a cross product. The cross product of vector A, B is a vector C, which is perpendicular to A and B both, but A and B cross is not equal to B and A because it's given by thumb rule, right hand rule actually. The magnitude of C, which is A cross B, is proportional to the sine of angle between A and B also. So A mod B mod into sine of theta, where theta is angle between A and B in the actually cross product. The direction of C follow the right hand thumb rule from A cross B. From A to you move to B of right hand thumb. It will, your thumb will be facing upward. So A cross B, the direction is actually upward, and the magnitude is of course A magnitude, B magnitude, and sine theta, depending on this sine of theta. So magnitude of the cross product, you know already, and right hand thumb rule also, A cross B. If you are going in the anti-clockwise direction, it will be upward. Clockwise direction you are coming, it will come downward. Magnitude, you know, direction of the cross product is given here also. It is called screw rule. Okay, so C into A cross B is actually, if you are opposite direction you are taking, it is actually minus B cross A is opposite in direction of A cross B. So this is the rule, and thank you. And actually I have to attend certain meeting at 4:30 of yours time. If we have some question, query, or suggestion, if you want for further exploring the mathematics, you can ask me. I am available for 2-3 more minutes. And the thing is, 2 hours are not sufficient to discuss mathematics. But the another thing is, mathematics is the basic. No, the computation, the coding you can do, or any other person will do for you. Chat GPT also can do. But the thing is, you should understand the mathematics behind that. Nowadays, when I try to write Python code, I never means first I never try it, or I should admit, I earlier also I would never used to write it. I used to take it from somewhere and then I used to modify it. Now that work is also now outsourced to Chat GPT. You do that using Chat GPT, but you should understand the things, the coding, the basic mathematics behind that. If you are thorough in that, you will be able to do all machine learning or data science work very easily. And the capability you can build is, of course, whatever the simple, even linear algebra, which we did, try using this, using R actually. So that will be another skill which will be very helpful for you. If you have any specific question, you can ask me. Otherwise, we will close that.